All right, guys, I wanted to explain the binomial theorem, hopefully in a little bit easier way than what some of the videos were that I had tried last year. First off, this is the formula for how to find a term in an expression. Now, you can use Pascal's triangle every time, which is what this was all about, okay? We had an IXL over that. But if you get to something that's a lot higher than the fourth power, you're going to be making that triangle pretty big. So it's not always the best way. So when we get something a little bit larger, we need to follow this form. Now, let me explain what this means. This is a combination formula like we've done in the past, and I kind of gave you that reference up here. Okay, the n this time means the exponent of the set. Like, is it a quantity squared? Is it a quantity cube? Is it a quantity to the fourth? The r is the term that I want. So if it means fifth term, sixth term, seventh term. Now remember, we have to be careful here because when we're talking in terms of terms, the very first term is my constant, which is actually term 0. So I wrote a little hint here. Whatever they want, like if they want the 13th term, r is actually that number minus 1, because we have to think about, oh yeah, there was that 0 term that's in there. So whatever term they want, subtract 1 off of it, okay? Then we're gonna take that times the first term raised to the n minus r times the second term raised to the r, okay? So that's our formula that we're gonna be using. Now I wanna give you an example of how we can do this, okay? So on example 3, they give me this problem. They give me, oh goodness, p plus q to the 10th power. And they want the 5th term. Okay, so if I look up at my formula up here, what's the exponent of the set? 10. I'm going to do a combination. What term do they want? They want the 5th term, but remember we have to think of 5th minus 1 because we have to eliminate that 0 term. So I'm actually looking for the 4th one is the way I think of it. It is called the 5th term, but it's the 4th one in line, okay? Then I'm taking, it says first term raised to the n minus r. So first term, this guy right here, raised to the n minus r, times the second term raised to the r, which was 4 in our case. Now I just have to clean this up. Now, we know how to do this combination. That combination formula is right here. We did it last section, okay? I also want to give you a hint of how we can do it on our calculator, okay, in case you want to use that. So if your calculator's on here and you go to math and over to probability, you have your permutation key and your combination key right there, right next to your factorial key if you needed that, okay? So if I want to do a combination, for instance, ours was 10 combination of 4, so I have to put my 10 in first, then I can type in my combination, and then 4. That's going to give me 210. Now, like I said, I don't mind if you do this on your calculator, but I need to see what you get out of that form. That's going to prove to me either A, you did it on your calculator, or B, you did it to the side. Either way, but that's going to tell me you did more than just copying it out of the back of the book, okay? That gives you P to the 6th. This gives you Q to the 4th. So if I were to FOIL this out 10 times, that 5th term would be 210 p to the 6th, q to the 4th. Okay? Now, the other thing you can do for this, sometimes they're going to say, okay, what about if I have, and this is kind of going off example 2, what if I have 2r minus s raised to the 3rd power? Now, you can actually do this 2 ways. You can use this formula for every single term. You can say, I'm to the 3rd power, and I want the 0 term. I'm to the 3rd power, I want the 1st term. I'm to the 0 power, and so on and so forth, all the way up to that term, okay? You can do that. Or you can use a combination of Pascal's triangle and knowing the pattern of how we FOIL, okay? And what I mean by that is when I have this power, when I I have to think to myself right now, I'm going to have 3 of these guys and no S's. And I'm going to keep working those down until I get no R's and 3 S's. So what I mean by that is when I start off, I have 2 cubed, R to the third, S to the 0. Okay? Then I have to think about that Pascal's triangle. You know, I was like this, right? Whoops. Okay, here's my 0, here's my 1, here's my 2, here's my 3 term. Okay, so my first term got multiplied by 1. He wasn't going to change. All right, then I have to think about my second term. My second term is 3, because I've got to have that coefficient, times I have only 2 squares now, okay, where I had 3 in the first. So everything's decreasing, only 2 R's and 1 S. Now I go again with this guy. Now I have only 1, 2. I have only 1 R, and my S is building, because remember we're building to S cubed. And then my last one, my coefficient is 1, so I'm not even going to write him. I don't have any 2's left. I don't have any R's left. S cubed. Okay? Now, the pattern of the signs is where I think is a little confusing here, but you're always following that negative with the S. So here, I technically didn't have any S's, so he gets to stay positive. Here, I had 1 S. That means I had 1 negative. Stays negative. Okay? Here, I would have 2 negatives. Well, a negative and a negative makes a positive. Here, I would have 3 negatives. 3 negatives makes a negative. I don't want you to think of that as a negative exponent. Now that I'm looking at that, I don't love that. Okay. So now my final answer, I can clean this up. I have 8R cubed, no S's, minus 4 times 3 is 12, R squared, S to the first, plus 2 times 3 is 6, R to S to the second, minus S cubed. Okay? I hope that helps.